Hey guys, welcome to the video for graphing systems of equations. We are in Unit 5. Our essential question is, what are the different types of solutions and what do they look like on a graph? So in Unit 5, we are introduced to more than just one equation when we're talking about problems. We're dealing with two equations. And two equations are called a system. So when I ask you to graph a system, you should have two equations on your graph. Now, there are multiple ways to solve systems of equations. So just like solving a single equation, we can solve a system of them. And when we solve a system of equations, there's three different ways we can do that. The first way is by graphing them. So graphing systems of equations is the first way you can solve them. There are two other methods for solving, but we'll learn that in the upcoming lessons. So before we get into all of that, we want to talk about what a solution looks like. So let's say I graph a line, and let's say that line looks like this. And it doesn't have to look exactly like mine, but let's just say I graph a line and it looks like this. And then I graph the other line. And then I graph the other line, let's just use green as well actually. I graph the other line and then it crosses and it goes here. Well, what do you notice about these two lines? What do you see them doing? They're intersecting, right? So two lines that intersect, I'm so sorry, there's noise in the background. Two lines that intersect, they intersect at one single point. So a solution is where they cross. So how many times do these lines cross each other? Just one time. So here we have one solution. Now I want you to think for a little bit, is it possible for me to have two completely straight lines and for them to only cross two times? So think about it. Could we have two solutions only? We can't, right? We can't actually have only two. So that's not possible. But we could have a line that looks like this, and maybe we have a line parallel to it. So what makes two lines parallel to each other? Well, they have the same slope. If they have the same slope and they're parallel lines, are these lines ever going to intersect each other? No, they never cross. So if they never cross each other, then there's no solution. And this only happens if we have parallel lines. Okay? The last case we can have is if we graph a line, let's say we graph our first equation, and then we graph the same equation again. On the second one, we graph the second equation and it ends up being right on top. What does that mean? Well, that means that my first equation was one line and my second equation was the exact same line. So they lie on top of each other. Well, how many times do these lines cross each other? An infinite amount of times. They're right on top of each other. They cross an infinite amount, like for as many points, right? So this is going to be infinitely many solutions. This happens if we have the same line. And we can shorthand this by saying IMS for infinitely many solutions. Okay, so those are the three types of solutions that we will see. Moving on to number 1, we have two equations here. Now, what do you notice about the form that they're in? They're in y equals mx plus b form. That's the easiest form for us to graph in, so the goal is to always try to get y by itself. Okay, your goal is to get y by itself because it's going to be a lot easier for you to graph if you have y by itself because it'll be in slope-intercept form or y equals mx plus b form. Now looking at my two equations, y is already by itself. So I'm going to start with the first equation. I have y equals 2 minus 1/2 x. Well, what's the slope of this first equation? It's negative 1 over 2 or 1 over negative 2. So it's been a while since we've talked about different slopes, but negative 1 over 2 is the same thing as 1 over negative 2. If I put both of those in my calculators, I'm going to get negative 0.5 for both. And then we want the y-intercept. Well, our y-intercept here is our b value, which is positive 2. So our y-intercept is 0, 2. Okay, so it is a y-intercept. That's where we're going to start. It's also known as our starting value. We want to plot it on the y-axis at positive 2. Okay, and the slope that we're going to use, I'm going to use the first one, but I don't have to use the first one. I could use the second one. Now normally I ask you to plot only 3 points at least, but I would prefer that for systems you plot as many as you can, because the more that you plot, the easier it is to see where your solution is. So you want to make sure you can plot as many points as your graph can fit. So we're going to use that first one. We're going to go down 1 and to the right 2, down 1 to the right 2. And when I run out of room, I'm going to go the opposite direction. Start at the y-intercept, go up 1 to the left 2, up 1 to the left 2. So I'm going to go ahead and I'm going to draw a line through all of my points. Now I like doing my systems in different colors just so I can tell the difference in between them. Now in the second equation, y is already by itself, so my job is easy there. What is my slope here? Well, my slope here is 3, but we want to write it as a fraction so we can do the rise over run. So this is going to be 3 over 1 or negative 3 over negative 1. So these are equal because 3 divided by 1 is 3 and negative 3 divided by negative 1 is still 3. And then our y-intercept here is 0, negative 5. So we're going to go down into the bottom at negative 5 on the y-axis. We're going to plot a point there. And we're going to go up 3 to the right 1. Up 3 to the right 1. Up 3 to the right 1. I'm going to draw a line through these points. Now, did you notice that one of the points that we plotted overlapped a point on the green line? They share a point at this section here. They cross once, which means it tells me I have one solution. Well, what is that solution? The solution is the point or ordered pair where they cross. So here it crosses at positive 2, 1. That's our solution to this system. All right, moving on to number 2. Now, at the beginning I said, hey, you need to get y by itself. But do you even see a y in this first equation? No. That tells us that it's either going to be a up and down line, a vertical line, or a side to side line, a horizontal line. Well, let's see what it's going to be. If it's just x and a number, that means I'm going to look at my x-axis because it's x equals. And I'm going to look and plot at the number positive 4 because it says x equals 4. Now, if you notice, all my tick marks on the x-axis go up and down. So my line on the blue is going to go up and down. All right, now there are points on this line all over the tick marks, but I don't write all of them just because it's a little bit tedious. So we know that there's points there, but we don't have to necessarily draw them. So this became a vertical line. Now this second one, x minus 2y equals negative 6, y is not by itself here. So I am going to have to get y by itself, and the first thing I'm going to do is I'm going to subtract x on both sides. So I have negative 2y equals negative 6 minus x. Well, my next step here is I'm going to divide all of my terms, because I want to get y by itself, by negative 2. So everything gets divided by negative 2. Well, negative 2 divided by negative 2 cancels, and that's just y. Negative 6 divided by negative 2 is positive 3. Now, be careful here. We have really a negative 1. Right? There's technically a 1 in front of that x, so we have negative 1 divided by negative 2, which is positive 1/2 x. So be super careful there. Negative 1 divided by negative 2 is going to make a positive 1/2. So our slope here is going to be 1 over 2 or negative 1 over negative 2. If you hear noise in the background, I think there's children running around the school, so I'm so sorry about that. So our slope is 1 over 2 or negative 1 over negative 2. And our y-intercept is 0, positive 3. So notice how every time I'm doing my systems, I do one equation at a time. So you plot one equation and then you do the other one. You don't want to do them at the same time or it can get confusing. All right, so I'm going to plot a y-intercept at 0, 3, and then I'm going to use my slope. Up 1 to the right 2. Up 1 to the right 2. I can go maybe one more, but I'm going to stop. So, what do I notice? Well, I see that it crosses my blue line, and it does cross at a point. I know we didn't put a point on the blue line, but there is a point there. Now, what is that point that they cross at? Well, they cross right here. And that solution is the point 4, 5. So it's going to be to the right 4 and then up 5. Okay, so that's our solution. All right, moving on. Number 3, we have 3x minus y equals 0 and 12x plus 8 equals 4y. Now, in both of these equations, y is not by itself. So because there's not a lot of space here, I'm going to split these up. I'm going to write 3x minus y over here equals 0. And then I'm going to write 12x plus 8 equals 4y on the right side, just so that I split up the space that I have to work with. Is it bothering you that that black line is crooked? Because it's bothering me a little bit. There we go, that's better. All right, so our goal here is to get y by itself. So the first thing I'm going to do is subtract 3x on both sides. Then we have negative y equals, well, 0 minus 3x is just negative 3x, so I don't have to write the 0 there. Okay, now y is not by itself. What number is in front of y right now? There's really a negative 1 here, right? So we want to get rid of that negative 1 by dividing both sides by negative 1. So then I have y equals positive 3x, because negative 3 divided by negative 1 is 3x. Okay, now there was an easier way to do this, and I'm going to do it on this side in purple, and I'm going to erase it in a second. Now normally we want our y on that left side, but do we always have to have it on the left side? Not really, right? So I could have just added y to both sides. And then I get 3x equals, what's 0 plus y? Just y. Isn't that the same thing? It is. It's just flipped on the sides, but they're the same thing. Now look at how much work I had to do for the purple, and look at how much work I had to do for the red. Now you get the same answer, one's just shorter, so it is up to you what you want to do. Okay. Before we move on to the blue, let's graph this red one. Our slope here, remember slope is going to be your m, it's attached to the x. Our slope here is positive 3 over 1. Well, what's our y-intercept? Well, remember the y-intercept is the number that's being added or subtracted, and there isn't one. So what's nothing as a number? 0. So our y-intercept here is 0, 0. So you're going to plot a point at 0, 0, and you're going to go up 3 to the right 1. And then since I ran out of room, I'm going to do the opposite and go down 3 to the left 1. And I'm going to draw my line. Okay, moving on to the blue. We want to get y by itself. Well, y is already by itself kind of on that right side. So I don't want to move y to the other side. Let's just get y by itself. Right now it's being 4 times y, so how do I get rid of the 4? You divide everything by 4. So now I have y by itself on that right side, but it's okay that it's on the right. It still works. 12 divided by 4 is 3, so we have 3x, and then 8 divided by 4 is positive 2. So our slope here is positive 3 over 1, and our y-intercept is 0, positive 2. So we have the point 0, 2, which is on the y-axis here. Okay, now you don't want to make the mistake and plot it here. What went wrong if I did that? So remember, that's a y-intercept. If you plot it on the x-axis, you're saying it's the x-intercept. So be super careful. You want to make sure it's on the y-axis. You want to go up 3 to the right 1. I ran out of room, so I'm going to go down 3 to the left 1, and then down 3 to the left 1. And then I'm going to draw a line through these points. Now, it looks like these lines never intersect each other, so I think they're parallel. But how can I double check to see if they are parallel? Well, parallel lines have what kinds of slopes? The same. So let's see if their slopes are the same. I have m equals 3 over 1 and m equals 3 over 1. Are these the same slope? Yes. So they're parallel to each other. Do parallel lines ever cross each other? No. So we have no solution. They're never going to cross. Okay. Moving on to number 4, we have y equals 2x minus 3, and then 4x equals 2y plus 6. Now, in the first equation, y is already by itself, so that's pretty cool, so we don't have to do much there. So let's go ahead and identify our slope. Our slope here is positive 2 over 1, and our y-intercept is 0, negative 3. All right, so we're going to first plot our y-intercept at negative 3. And then our slope, we're going to do up 2 and to the right 1. Up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And then I'm going to do the opposite in one direction over there. All right, now over here at the second equation, y is not by itself. Now, what side is the y on already? It's on the right side. So let's just keep it over there and make our life simple. So in order to keep the y on that right side and keep it by itself, to get it by itself first, we need to do what? Subtract the 6. Now 4x and negative 6 are not like terms, so you would just write them right next to each other. And then to get y by itself, you divide everything by 2. So you have y equals 2x minus 3. Our slope here is positive 2 over 1, and our y-intercept is 0, negative 3. So I'm going to plot the point 0, negative 3. I go up 2 over 1, up 2 over 1. What do you notice? They're the exact same points. Well, if you look at your equations and you look at your slope and your y-intercept, what do you see? Our slopes are the same and our y-intercepts were the same. They're exactly the same, aren't they? They're both the same. That means it's the same exact line. So this line crosses an infinite amount of times. This is infinitely many solutions. And the short way to write this, we can write IMS, but I like to write out infinitely many solutions. So these cross an infinite amount of times. All right, so there's 3 more problems. I'm going to cut the video because I have a phone call to make, and then go ahead and just watch the second part of the video once you finish this first part.